Today, in this session, this is the last session, as you know, and in this session, we will cover Medicare Risk Adjustment Score calculation on a real-world use case. After a short introduction, then we will go over the Medicare Risk Adjustment concept. I will try to explain why it is needed and where it is used for, and then I will show some sample case studies. After that, we will talk on, I will try to show that impact of appropriate HCC coding on payment. Then we will talk on an example of HCC scoring and patient risk adjustment score calculation. At the end of the session, we will go over coding on a real-world use case. Maybe you may remember that this presentation from the yesterday sessions. If someone missed this, let me explain it shortly. Again, as you know, healthcare NLP library sits on the shoulders of Apache Spark itself, so it can use the distributed system advantage of Apache Spark, and it has been downloaded more than 100 million times according to the PyPy statistics, and it is most widely used NLP library in the enterprise. So the 59% of the healthcare NLP teams use the healthcare NLP library. Also, we have some peer-reviewed papers that you can find the architecture that we use at the behind of this library, also the benchmarks that we got so far. You can find all the peer-reviewed papers on our web page, by the way. What is Medicare risk adjustment and why we need this? In the United States, the CMS, Centers for Medicare and Medicaid Services, considers how healthy a Medicare plan enrollees are when determining determining how much the plan gets reimbursed. So to do this, CMS uses a system called HCC model, the hierarchical condition category model. And this model assigns RAF score. The IRF score is risk adjustment factor score to each Medicare patient. This score, the RAF score, is essentially a health complexity score. It considers the patient's diagnosis conditions using the specific codes and assigns a higher score for the people who has more serious or chronic illnesses. These scores then used to estimate how much future medical care each patient is likely need. As a result, so the Medicare Advantage plans that enrolls sicker individuals, I mean like with higher RAF scores, get reimbursed more because they are expected to incur higher costs providing care. Right, so this helps ensure plans are fairly compensated for the health needs of their members. These are the latest case studies that were presented in the NLP Summit that Johnson Labs organizes, and in the aquatic use case, in the project, it is about a solution built with the healthcare NLP library to address the challenges in risk adjustment in healthcare. The traditional risk adjustment models are based on claims data, which excludes about like the nearly 40% of risk adjusted conditions. This results is underpayments for health plans and providers, which is a large amount of data, right? And so in this project, they try to explain the solution they built to extract clinical information from unstructured nodes and use it for the risk adjustment score calculation. Their solution uses a combination of the rule-based and the machine learning-based methods to identify valid and counters split documents into individual visits and also extract information such as ICD diagnosis codes. Also, you can find what kind of challenges they faced while working on this task just click on the title here, and it will direct you to the YouTube video of this presentation. With the Databricks, Johnson Labs team has prepared this presentation, and we try to extract the risk factors for the life insurance underwriting. Like sometimes we cannot get all the information about the patients, right, or the people when we just control the tabular data. So there are several kind of information hidden in the unstructured notes, right? So we need to extract those information, especially for the insurance underwriting. So we need to consider those information also, right? We leverage the NLP tools to extract that information, like smoking status, alcohol, or substance usage, or some diseases in the family. If we have a map, great map with this kind of information, we can accurately calculate the life insurance, right? Life insurance payments for people. So you can find the details in this presentation. Like, what is the impact of the appropriate HCC coding on the payments? Like, let's assume that there's a female patient. She's at 76 and originally disabled, Medicaid, and also these information are coming from a tabular data. According to this demographic information, the risk adjustment score is just 0.448, okay? But if we extract the information from the unstructured data, some more additional information, like the obesity and the other diseases like asthma or type 2 diabetes, you can see the effects of them on the risk adjustment score. And the rough score is 1.028 when we get the information from the unstructured data, okay, and calculate the rough score again accordingly. So the annual payment is gets higher, right? $90 it has been, but if we extract information much more accurate way and map them to the HCC codes using these detailed information, so we can calculate the risk adjustment score much more accurately, right? Like, for example, if we just use the obesity if we just use the obesity, its effect is 0. But if we use the morbid obesity, this is another information, and the BMI index, so its effect is greater than this, right? You can see all the HCC scores are here, increased, except this one. All the diseases, if we extract these diseases with some additional information by combining them together with according to the context or using the negation statuses, etc., or some relation extractions, then we can map these entities to the HCC codes much more accurate and calculate the rough score, right? This is nearly 3 times higher than the previous one. And the cost is 22K. This is crucial. This is why the calculating HCC score is a crucial task. Okay. Here is a simple clinical note on the screen. So it is unstructured completely, and there are some abbreviations inside, and there may be some typos, and there are dates. For example, like there may be some clinical test results, also some PHI information here. So we need to extract some information from here, right? We can leverage the NLP models to extract the information from here and filter them according to the HCC concept, then use those valuable information in our RAF score calculation, right? But extracting the entities is not enough enough only. So we need some additional information. For example, we need to check their negation status, right? If we just use the pulmonary embolism and include this into our RAF score, this will be incorrect, right? Because there is no evidence information here. So we need to exclude this, also this one, for example, or if there are some diseases related to the patient's family, so we need to discard them also, right? So the first thing that we need to do is extracting the entities. After that, we need to check their negation status. Maybe sometimes we need to use the relation extraction models as we did in the oncology use case yesterday, okay? Here's a table that is extracted from the clinical notes. And as you can see, we also check their negation status here. And for calculation of the ICC scoring, since it is present, we just filter the present ones. After that, we cannot directly use all the ICD-10 codes in the RAF score calculation, because there's a hierarchy between the ICD-10 codes. Okay, this is why its name is hierarchy condition category risk score calculation. So what is the hierarchy means here? Like, for example, the diabetes plus acute complications has higher score than the diabetes chronic complications, and also it is higher than the diabetes mellitus. This has low score, and this has medium, and this has high. But since there's a hierarchy between all these clinical conditions and also in the ICD-10 codes, so it uses the ICD-10 code with the higher score only. Okay, it doesn't. It discards all the other subcategories. Okay, it just used the higher score, and this is the same for all the other ICD-10 codes. It checks the hierarchy first, and then include or exclude some of them in the score calculation. Okay, not all the positive diagnoses belong on problem list, right? So just because the doctor finds something during the visit, like positive diagnosis, doesn't necessarily mean it should be added as a permanent problem. So as you can see here, like there's an upper respiratory infection, but since it is an acute condition, this cannot include it. Okay, since it's acute. But if it is chronic, we need to include this. So we need to check this information, right? Also, not only the entity itself, right? So LLM model can excel in this kind of reasoning, and they can help with the reasoning by analyzing the patient's note and the problem list and new findings to suggest updates, right? But we need to keep the human in the loop, because a doctor reviewed and approved the LLM suggestions, like the new problem list, and then but the doctor should say the final word, since it's a really crucial task, right? Here's an example how you can calculate. Here's an example of our demo that we showed an example on HCC risk score calculation. We need some, even though we can extract some of the information from the unstructured data, still we need some information externally, like eligibility information or OREC or Medicaid informations. Again, some of them can be extracted from the clinical note, but we need some information from externally, right? We also have some age models. If we don't have the gender information in our external table, we can use the Spark NLP gender classification model, okay? And for the age detection, we can use NER models. Like this kind of NLP works can be done. After that, we achieve the risk score calculation. So we have a module for this, for calculating the risk adjustment score. I will show an example of the demo page. Let's assume that an insurance company faces the challenge of accurately calculating the Medicare risk adjustment scores for their enrollees and using their patient notes. They have some patient notes and they want to calculate the risk adjustment score accurately. So if they have millions of notes, this is really time-consuming task and error-prone, also labor-intensive, right? So they need to automate this process. Also, human can make some mistakes by deciding the ICD-10 codes while deciding the ICD-10 codes for different patients, right? Sometimes they can say that like this code is for type 2 diabetes mellitus, this is the code, but sometimes they may miss this, right? Instead of having this issue, we can, when we automate this using the NLP tools, all the results will be deterministic, right? And then we can have faster results also and deterministic results at the end. So there are some keywords here. The problem is calculating the Medicare risk adjustment score, and also it wants us to check the clinical conditions, age, and gender informations of the patients from the clinical note. How we can solve this problem? So we can use the NER models first, right, to extract the entities, but we need to use more than one NER model to have a robust pipeline, right? Generally, we suggest customers to do that because sometimes since these are the deep learning models, sometimes they can miss some of the entities, right? In case of this issue, if some of the NER models misses, some other NER models can extract that missed entity, right? So we suggest customers to have a robust pipeline by combining some NER models that are that has related entity labels with the ICD-10 and also the HCC score concept. Okay. After extracting the entities, then we need to check the negation status of those entities. As I explained before, if they are related to someone else or with the patient's family members, or if they are absent, like no evidence of carcinoma, for example. So we need to discard this one, right? And this is why we need the assertion models in this process. After extracting the entities, we check the assertion status. Then we map them to their corresponding ICD-10 codes to calculate the HCC scores. Okay. Also, I will try to show how you can use the Q&A models in this process, how you can leverage the Q&A models for achieving some of the missing information. Like this is our model subpage. As you know, you can join our Slack channel from here, and you can check our GitHub repo from this link. Then if you would like to check what kind of models we have, you can just type here the related information, like for example, HCC. These are the models that we have and the pre-trained pipelines also, right? Also, you can filter from here, like chunk mapping or entity resolution, or like the healthcare NLP version, or open source, also the language information from here, okay? When we jump over the demo page, we have several demos, and here the day identification, like adverse events, laboratory results, radiology, oncology, also entity resolutions of the terminologies according to the terminology codes, right? And this one is about risk factors. Yeah, here it is. When we click on this, yeah, here is a clinical note, as you can see. And when we click on this one, you can see the detected entities over this page and their ICD-10 codes, their labels, their ICD-10 codes, and the resolution of the ICD-10 codes easily, okay? Like acute renal failure, this is a kidney disease, and its ICD-10 code is here, okay? So then we have some, as I explained, we have some external, we need some external information like age. Please note that here is the risk score. It is changed according to the age information, as you can see, like when we change the gender of the patient, it also changed. Also the eligibility information like OREC, and if it also depends on the if patient has Medicaid or not, okay? And these are the entities detected by the assertion model. The filter, when we filter according to their negation statuses, these are the present ones, okay? Then we calculate the risk adjustment score accordingly. So there are several versions of this module that we have, like for example, the version 28. Also, you can have the year year. We also have the year versions of for each these versions. Okay, like for version 24, there are year versions also. Okay, for 2020 22. So this is the another model, and when you click on this, the results may be changed because they make some updates over the years. So we try to adapt all of them and keep our own models updated. Okay. So here are the OREC information here, like and explain. When we click on this, we can check what does these abbreviations mean, okay? So let's go over our notebook, and here is our workshop repo. And then when we go over the tutorials here, we have certification training notebooks, and you can see all the notebooks that we have from here, okay, for all healthcare NLP components that we have. And the notebook that we will cover is under the medical language models, and here is the Medicare risk adjustment use case. Under the workshop report, tutorials, certification trainings, and medical language models, okay? So when we click on here, notebook will be open, and then there will be an open collab button. When you click on this, the notebook will be ready. Okay, you will just upload the license that you have. After that, we just install some libraries that we will use. Like this Spark NLP display library is used for the visualization of the results coming from the NLP tools. Okay, like assertion, relation extraction, entity resolution, and NER. And we start the Spark session. After that, we use oncology model, oncology dataset, open source MT samples, oncology dataset here. There are just 10 clinical notes in our example here to make it fast. And then here is a sample clinical note example. Like there are some section headers, and we can also detect the section headers by using our NER models. And also, if there is no section header in the clinical note, and you are interested in some part of the clinical notes, you can also split the document into smaller parts and classify them by using them section header classification model we have, and just filter the sections that you are interested in and run the NLP pipeline on specifically those filtered sections, okay? For the ICD-10 code extraction, as I explained, you can use more than one NER model in the pipeline to have a robust pipeline like this. You can just check on the model sub page, and for example, NER clinical, okay? for the NER clinical, this is an NER model. We can filter this. And then here for English, we need, okay. And you can just check the model from here on this page, and then copy the code. After that, like for example here, okay, like this model can extract the problem entities. This means clinical problems, okay? And you can just copy the model from here like this and add it to your pipeline. Add another model, then you need to use the chunk merger here. Chunk merger. I explained the chunk merger in the yesterday meeting, like this one, and merge the results coming from these models since they have the same names. So you can just copy here and merge their results, okay? Please do not forget to change the variable names here and also add these new states to the pipeline, okay? So here, let's remove this one. In this example, we just used a single NER model, which is GSL, and we just filtered the entities that are related to the oncology, also related for the ICD-10 and the HCC score calculation concept. Just 3 labels we just whitelisted, and it has more than 80 different labels. You can just whitelist all the related labels, okay? We just show an example with these 3, okay? Like oncological, disease syndrome disorder, and heart disease information we got, entities we got from the text, okay? After the entity extraction, we get the embeddings of those entities and send them to the ICD-10 resolver model, and we check the assertion status of them. Okay, like here are the entities that are detected by the NER model, and then these are the resolutions coming from the ICD-10 model, okay? So, for example, here, and these are the assertion status of those entities detected by the NER model. So we can discard the absent ones, okay? Also related to the family members or someone else, okay? We need to do that. So after getting the ICD-10 codes, we can group by the results as shown here to make them predefined and check easily. These are the ICD-10 codes of the patient 1, and these are the ICD-10 codes of the patient 2, okay? After having a list of this, if we don't have the gender information, we can use gender classifier model that we have, which is trained with the BioBERT model. BioBERT embeddings, since it is context aware. So these are the results of the clinical notes. When we just feed the clinical notes to this pipeline, it can just classify the genders according to their genders, okay? If we don't have the gender information, so we can follow this stage and use this gender information in our risk score calculation. Also, if you don't have the age information of the patients, we can use the NER models for this, right? Just extracting the age information from the clinical text. But sometimes this can be, this can have some risks actually while the calculation. So in here, there's only one age information, but there may be some more, right? Also, some of them may be related to someone else. It's not only for the patient. Okay, so dealing with these kind of issues, we need to do some pre-processing or mid-stage processing over here, just before feeding the results to the HCC calculation. Okay, these are the age information of the patients. So while calculating the Medicare risk adjustment score, we have module for this, for the risk adjustment score calculation. Okay, these are the informations that we extract so far, like ICD-10 codes, age information, and the gender informations, as you can see. So, and also, as I explained, we need some external information like Medicaid or OREC, eligibility, this kind of information we need. If you don't have the age information, you can also feed, you can also use the date of birth information. These are the external, this is the external table. So when we concat them, okay, when we concat them, this is the final table that we have: date of birth, Medicaid, OREC, eligibility, gender, ICD-10 codes, and their resolutions. The resolutions will not be used, just for checking the results. We just showed here, and age, also the file name, the patient ID, for example. These are the profiles that we have for the risk score calculation that we use. So like the versions and their year information, like year 17, year 18, as you can see. Also, we have the RxHCC model to calculate the RxHCC score. Okay, you can just import the profile as shown here and feed the information that you have like this. Then it calculates the risk scores for each patient. Okay, when we check it in a detailed format like this, these are the informations that we extracted and used in the risk score calculation. This is the HCC profile of this patient, and this is the HCC score, as you can see. And these are the HCC lists. This means the HCC codes of the ICD-10 codes. Okay, there are 3 ICD-10 codes, but there is only 2 HCC lists here because, as I explained, some of the ICD-10 codes has not any effect on the risk score calculation. So they were discarded according automatically in this in the process while we are calculating the risk score. Okay, you can see from here, like this one is a higher one. Okay, and this is the example of the RxHCC. This is the same, but the RxHCC calculation doesn't need to have the Medicaid information, but it needs the ESRD information of the patient. So the method is the same, and so these are the RxHCC scores of this patient. Okay. If you don't have some information that you need to provide in the RxHCC module, so you can also leverage the Q&A models. Like, for example, if you don't know the age or gender or the diagnosis information of this patient, you can just feed the clinical text to the Q&A model that we have, like this, okay? And then it can return the results accordingly, right? The patient is 58 years old, and like here, she's 58 years old, and the other informations. Okay, so then you can use the NER model on this and concat the results coming from the Q&A model and coming from the NER model, as we did before, and use the gender classification model also to double check and entity extraction, then calculate the risk adjustment score with the same method. Okay, as you can see here. There are some utility functions in this module also, like HCC from ICD or ICD to HCC. If you would like to check the HCC cost of the ICD-10 codes, you can use these utility functions that we have to be sure or to check the performance of the module. You may sometimes need this because all the things has been calculated at the behind of the stage, so you may not be aware of which HCC score is used. So if you would like to check this, you can use these utility functions. Okay. Okay. Thank you so much for joining this session, and all the links that you will need in the exam of the certification training, or that we shared during all these sessions will be shared with you right after the session ends via email. Please check your spam box also, okay? And do not forget to join the Slack channel that we have. It is completely public, and you can ask your questions over there. And if you would like to ask some specific questions, please send your email to the support@johnsonlabs.com, and see you soon. Thanks for joining.